Okay, in this video I will go through Mechanics 1, Chapter 10, Section 10.6, and the title for the lesson is Pulleys. Okay, it is another sort of connected particle. In previous video we went through the connected particle on straight surface. Okay, but in this video we're going to go through the connected particle on pulleys, surface and pulleys as well. Okay, so example 13. Particle P and Q of mass of 2m and 3m are attached to the end of a light inextensible string. The string passes over a small, smooth, fixed pulley, and the masses hang with the string taut. The system is released from rest. Okay, so A. So first of all, let's write down all the information. Okay, so here is a pulley. Okay, so let's say here is 3m, and let's say this one is 2m. Okay, so let's write down all the forces which are acting on these two particles. Okay, right. mg, 3mg. This one is q and this one is p. 2mg downward. There is always tension here and tension at this point. Again, tension in this direction for P and tension in this direction for Q. So the acceleration should be in this direction. Okay, let's take this direction as a positive acceleration, and for this one it would be upwards. So the pulley, the particle will move like this. Okay, so part A part 1. Write down an equation for motion of P. Okay. To write an equation for P, so here is P, so all the forces are existing or entering to P basically. Okay, so we don't include this T, we have to include these forces. First of all, it's moving upward. Okay, all the forces are this direction, so T minus 2mg is equal to mass times by acceleration. What is mass? 2m times by acceleration. That's part 1 for A. Part 2. Write down an equation of motion for Q. Okay. So for Q will be in this direction. 3mg minus T is equal to mass times by acceleration. Okay. B. Find the acceleration of each masses. Okay. We have two equations in terms of T and A. Okay, so what we need to do, let's call this one equation 1, this one equation 2. Okay, adding equation 1 and 2, equation 1 add equation 2. Okay, so T add minus T is 0. Minus 2 mg plus 3 mg is 1 mg. Okay, so 2 ma plus 3 ma equals to 5 ma. Divide both sides by m. We get 5a is equal to g. Therefore, a is equals to 1 over 5g meter per second. Okay, part C. Find the tension in the string. Okay, so we need to find the tension in the string. We already worked out acceleration. Okay, so using equation 1 or 2, we can work out the tension. Using 1, we get T minus 2 mg is equals to 2 ma. A is 1 over 5 g. T minus 2 mg is equals to 2 over 5 mg. Therefore, T is equals to 2 over 5 mg plus 2 mg. And finally, T is equals to 12 mg over 5 newtons. 12 over 5 mg newtons. Okay. However, we worked out in terms of m and g. And we know that g is 9.8 anyway. Okay. Part D. Find the force exerted on the pulley by the string. Find the forces exerted on the pulley by the string. Okay. To do this, all we need to do is just sketch the diagram again. We don't need to sketch the full diagram. Okay. Here is the pulley. Okay. This is a string. Okay. T in this direction and another T is in this direction. Okay. So the forces exerted on the pulley by the string is t plus t, because both are in the same direction, 2t newtons. And the direction is downwards. However, you can substitute the value of t and you get 24 over 5 mg newtons. They are the same thing. Okay, the next part of the question, part E. Find the distance moved by Q in the first 4 seconds. Find the distance moved by Q in first 4 seconds. Okay, the distance moved. As soon as it says distance, we have to use the Silva equation. So S U V A T. Okay. We are looking for distance. Okay, question mark. Initial velocity is 0 because it's starting from the rest. We don't have the velocity. Acceleration is 1 over 5g, which we already worked it out. T is 4 seconds. Okay, so we're going to use S equals to ut plus half a t squared. Okay, so u is equal to 0, 0 times by 4, add half times by 1 over 5 g times by 4 squared. Okay, substituting 9.84g and using your calculator, you should be able to get 15.7 meters. Okay. And finally, the last part of the question. Part F. State how you have used the fact that the pulley is smooth in your calculation. Okay. That the pulley is smooth. Okay. We want to explain this. The tension in the string is the same at P as at Q. So the tension in the string is the same at P as at Q. Okay, end of the example 13. Okay, so you can see the full solution here. Okay, so I was planning to go through the example 14 as well, but the video will be too long. So next video we can go through the example 14. Okay.